This is a lesson on compounds. Get ready to learn. We all know this water molecule. Why is it important? Atoms make up everything. Atoms combine to make new materials. We can design new materials based on our understanding of how they combine. Did you know? Chemistry is the study of matter and the changes it undergoes. Compound is two or more atoms that are combined. See these links here between atoms. They combine chemically to form something new. It's different than what you started with. Not the number of atoms, but how they combine. They're always in the same ratio. This is a molecule. Another molecule from the other side of the room will be the same. We all know water. The water molecule always has two hydrogen atoms. 1, 2. Always one oxygen. Well, Democritus. He was an ancient Greek, one of the first to have an idea about atoms. We don't have a picture of him because it was a long time ago. He called the smallest part atomos, atoms. John Dalton. It's not a picture of him, but it is a painting. Early 1800s. He said that all matter is made of tiny particles called atoms. Found that atoms are indivisible. You can't break them up. You can't divide them into something smaller. Normally. It takes a lot of energy and a lot of machinery to do that. So, you're not normally going to do it. Atoms do not break apart. They're neither created nor destroyed. You break an atom apart, you have an atomic bomb. Not easy to do, so don't worry about it. Atoms of different elements, they differ in mass and other properties. That's what makes them different. In a given compound, the combinations of different types of atoms are always present in the same ratio. Remember our friend water? 2 hydrogen, 1 oxygen, H2O. H2O from the other side of the room would be the same. J.J. Thomson, he discovered the electron. He won a Nobel Prize in 1897. This is not a long time ago. 120, 30 years. He did cathode ray tube experiments. That made the early TVs possible. Here's his experiment. And it made the early TVs, if you see pictures of TVs with a big glass tube in the front, not the thin ones that many of us have today, made television possible. Niels Bohr. He designed a model of atoms that had electrons at different energy levels, like different planets orbiting the sun, different orbits. He gave new understandings to atomic structure. And you can see here we have one level with 2 electrons in it. And the third electron comes in at a different energy level. And then if you get even more, you can get more energy levels. And that's the Bohr model. He had a real good understanding of what happens inside an atom. Now, because of all these people, we have an understanding that some atomic parts have an electrical charge. Protons, they're represented by the red ones here, they have a positive charge. Neutrons, those are the white ones here, well, they have no charge. And the electrons, these things out here, they have a negative charge. Now, atoms are balanced when the charge equal to 0. So the number of positive and negative and no charge should equal 0. So if you have 1, 2, 3 positive and 1, 2, 3 negative, and of course neutrons have no charge, 3 positive, 3 negative, this is a balanced atom. Compounds. Compound is 2 or more atoms that are chemically combined. They combine to form something new. It's not the same as what you started with. The number of atoms is the same. They're combined differently, though, in a chemical reaction, which makes a compound. They're always in the same ratio. A water molecule is always going to have 2 hydrogen and 1 oxygen atom. Now, chemical reactions. Atoms are combined chemically. They share electrons. Reactants, the things that react, what you start with. Products are the result of a chemical reaction. This is kind of a shorthand way of recording that. A plus B reacts to form AB. You can also go the other way. What you start with after a reaction, you wind up with something different than you started with. The same amounts are there, but they are different. They have different properties. And you can replace one with the other. You can replace 2. So you've got different kinds of chemical reactions here based on the atoms and the elements themselves. But the law of conservation of mass says no material is destroyed or created. What you start with is what you end with. What you start with is what you end with. What you start with, what you end with, what you start with, what. Nothing new is created nor destroyed. We've seen this. This is the periodic table. Chemical symbols. They're made up of a single letter or sometimes 2 letters, because after you get to 26 letters, you need to do something. The first letter is always capitalized. If there's only one letter, then it's capital letter. But that's so you can tell when one element stops and the next one starts. The names sometimes come from Latin or Greek words. Sometimes the letters don't really match up with, like Na for sodium, but it comes from the Greek word for sodium. Mg, magnesium, that makes sense. Ne, neon. He, helium. Okay. The forces in an atom. In a nucleus, all charges are either positive, remember the protons, or neutral. Remember, the neutrons have no charge. Well, if all you have is positive charges in here, like poles of a magnet, you put two north poles together, they're going to want to repel each other. Same with positive forces, positive electrical forces. But there are even more powerful forces that are called nuclear force that holds the nucleus together. If you overcome that nuclear force, a nuclear reaction happens and there is so much energy released that you can drive a submarine. So, why is this important? Atoms make up everything. Atoms combine to make new materials, and we can design new materials based on how they combine. And there's your lesson on compounds.